class, today we are talking about section 1.5, which is algebraic equations. By the end of today, we'll be talking about simplifying equations to solve for a single variable. Some vocab that we got going on. An equation is an algebraic expression that contains an equal sign. So for example, x plus 7 is equal to 10. The key thing being the equal sign. An expression does not have an equal sign. An equation does have an equal sign. The solution is the number or value that replaces the variable to make it a true statement. So in the case of the example I just gave, x would be equal to 3. Part of what your book is going to talk about in today's lesson is a replacement set. So that's a whole list of numbers that you could plug in for the variable. And the goal would be to decide which one works. So the squiggle lines are a different type of bracket that we haven't really talked about. You'll see what they're actually supposed to look like on the next slide. But the replacement set of 1, 2, 3, 4, 5 is numbers that we could plug into x in that original equation. And the solution set is the number or numbers that make the equation true. In this case, the only one of those numbers that makes that statement true is 3. So 3 would be your solution set. So as you can see in this example, those brackets that I was talking about, that's what they're actually supposed to look like. But they're giving you the replacement set of 2, 3, 4, 5, and 6, and asking you what the solution is for the equation 2q plus 5 is equal to 13. So what you would have to do is plug in each of the numbers into the equation and decide which one of them is true. So into the first one, I plugged in 2, the second one I plugged in 3, then I plug in 4, 5, and 6, and now I have to decide which one of these is a true statement. The first one, 2 times 2 is 4, plus 5 is 9. Not true. 2 times 3 is 6, plus 5 is 11. Not true. 2 times 4 is 8, plus 5 is 13. That is a true statement. 2 times 5 is 10, plus 5 is 15, doesn't work. 12 plus 5, again, does not work. So the only number from our replacement set that turns into the solution set is 4. Again, because we're talking about a set of numbers, that's why the brackets are around our final answer. Go ahead and try this one on your own. Make sure you are testing all of the numbers. So you should have gotten a final answer of a solution set of 5. Again, none of the other options actually makes the statement true. The other part that we're going to talk about today is solving the equation for a variable when the variable is already isolated or set alone by itself. When a problem is set up like this, you are just going to go through and use PEMDAS to solve the side of the equation with the numbers. So first we've got 7, solving inside the parentheses, we get 16 minus 10 plus 10. Next step, finish up those parentheses to get 7 minus 6 plus 10 is equal to n. You should always keep that variable on the end so you know what you're solving for. 7 minus 6 gives us 1 plus 10 is equal to n for a final answer of 11 is equal to n. If you prefer to flip it around and write n is equal to 11, you are allowed to do that using those properties that we discussed a couple lessons ago. Go ahead and try this one on your own, making sure you are solving step by step and using PEMDAS. So in this case, again, you get an answer of 11 equals n, or you can flip it around to n is equal to 11. Another thing that we might have going on is having variables on both sides of this equation. Again, you want to address it the same you would with the last two problems, solving your PEMDAS steps first. So looking at the left side, you're going to want to solve those parentheses. 3 plus 2 gives you 5, so I've got 5x plus 6 is equal to 5x, and I can simplify 10 plus 3 to give me 7. Now, if you notice, notice I have 5x's on one side and 5x's on the other side. Those are equivalent, so I can ignore them for a minute. So now my equation says 6 is equal to -7. As we all know, that is not possible. So this introduces us to a new type of answer, which we call no solution. What this means is no matter what number you pick out of any number in the world, if you plug it in for x, you will never get the two sides of the equation to actually be equal to each other. So this problem is actually not solvable. On the flip side of that, if I go ahead and go through and solve this problem, I've got 12 times 10 minus 7, which gives me 12 times 3 plus 9g. And simplifying the right side, I've got g times 2 squared is 4 plus 5 plus 36. Taking a next step in PEMDAS on both sides, I end up with 36 plus 9g is equal to 9g plus 36. Again, you have the same amount of variable on each side, so we can ignore those for a minute, and our statement now says 36 is equal to 36. This is a true statement, so it gives us the opposite case of what we just had, and we're going to call this all solutions. What this tells us is no matter what number you plug back into your original equation, it will always turn out being equal. So if we go back and make a quick observation, the first one, we had matching variables and different numbers. That gave us no solution. So 5x plus 6, 5x minus 7. Variables match, numbers are different. It's no solution. In our second case, we have the variables match 9g and 9g, and you're adding the same amount to both sides, 36 and 36. That gave us all solutions. So when you are looking at these problems, if you end up with the same amount of variable on both sides, all you need to do is look at the other numbers to figure out if it's going to be a case of all solution or a case of no solution. Last thing we're going to talk about is everyone's favorite part of the lesson, which is a word problem. Mr. Hernandez pays $10 each month for movies to be delivered by mail. He can also rent movies in the store for $1.50 per title. Write and solve an equation to find the total amount he spends this month if he rents 3 movies from the store. So the first thing that happens is we got to break this down into our important pieces of information. First key piece is that he pays $10 each month for movies to be delivered. That's going to happen regardless of whether he goes into the store or not. So we know that he has $10 per month. Then if he goes into the store, we know that he's paying $1.50 for each movie that he rents. Finally, our question is asking what's going to happen if he rents 3 movies from the store. So we got to put this all together into an equation to solve. So the first part we said is he's paying $10 for that rental fee. Plus, we got 3 movies at $1.50 each, and we are looking for his total price or his total cost, which I'm just going to use the variable p. That's standing for the value that we don't know right now. Solving the left side of the equation, we're going to do our multiplication first. So we get 10 plus 450 is equal to our final price, giving us a final answer of $14.50 for his cost. Since it is a word problem, one of the key pieces of information that I will be making sure you are doing all year is word problems need to have a label or a unit on it. In this case, we are talking about money. You need to make sure in word problems that those labels are there. If you have any questions about this or anything else we discussed in the lesson, please let me know when you get to class.